CodeWalker shows you how any given piece of code really works. It does this by walking through your code, figuring out how the code connects to itself, and then mapping out every possible way the logic in your code could play out. The calls filter lets you easily see your original calls as they appear in the newly mapped out context. As you can see, this section is the same as this one, and this code is the same as this and this. CodeWalker has reassembled your code and is showing you the actual paths of execution your code will take. Now we can clean up the display by hiding parts of the code that are in use elsewhere using the trim filter. This is a closer representation of what your code will actually do. Let's look at a more complicated example. If you click the calls button a few times, it will toggle through various color combinations. Just pick one you like. In this case, I've taken some fairly simple looking source code, but as you can see, there are a number of slightly different paths this code could take, depending on what functions are called first. First, I'll use the trim function to show only the most inclusive paths this code could take. And this is how that code would work. Let's use the heat map filter to discover areas of our code that exist inside nested loops. And since CodeWalker has already reassembled our code, these nested loops can exist across multiple calls and functions. Loops are easily identified by a circle around the start of the name. The colors here are pretty easy to understand. Gray means no loops. As the number of nested loops increases, the colors go from blue to yellow to red to show areas you might want to look at during optimization. Now we're going to look at the source code to a non-player character in a game. It's not crashing, it's just not behaving in a way that we would expect it to. In fact, it's not doing anything at all. So we're going to use Retrace. Retrace is a powerful feature of CodeWalker that combines logging and debugging, and lets you scrub back and forth through the execution of your code like watching a digital movie. To use Retrace, we just follow the instructions accompanying the app, and here we'll import the final Retrace file. As you can see, not a lot is going on. If you look at the scrub bar at the bottom of the screen, it is moving through the code at a pretty rapid pace, but the green line indicates that the same thing is happening every step of the way. If we zoom in on that line, we will get a better idea of what is happening. If the player transform is null, then we look for objects with a tag of player, and if that fails, it goes to the else statement. A quick tweak in the game, and we now have a character with a player tag. And looking at that retrace